Well, hello everybody. Let me run my plans by you today. The main part of the lesson, of course, will be I need to cover section 4-3 with you. I'm going to divide it into two separate days because there's a lot of factoring on the second day. But my plans are going to go like this. I'll answer any questions that people had on section 4-2. I will give you a skill check over section 4.1 and 4.2. It should be easier than the worksheet that we had the other day, because what I'd like to do is come back next time and quiz you over section 4.1 and 4.2. So that would be the power rule, the product rule, and the quotient rule, and any type of applications I'd like to toss at you. But on to the main lesson. Hopefully you got your note sheet right in front of you. I did retype it so you wouldn't have to fight how small my PowerPoint is, so sorry if you got one of those old forms, but hang with me. Section 4-3 is divided up into two different parts. There's the composition of functions, which should be reviewed from your Algebra 2 days. I'm just going to briefly touch on that. And then I need to show you the chain rule. It'll be our fourth rule, and there is a formula that you'll be able to put onto your note card. And then the assignment today will be off of Math Excel once again. It's not a bad one to type in. Next time's is, so we will not use Math Excel next time. So hang with me on this. Let me review composition of functions with you real fast. A composition of function just means I'm trying to put one function into another function, basically to create a third function that'll take me from the first to the third. Here's what I mean. Look at this example that I made up. An internet store is having a 25% off sale on any items purchased over the web. They will then add in 6% sales tax and then $10 for shipping and handling. So here's what I did. I just made up a couple of examples for you just to kind of show you. If you were to buy a $100 item, they're going to give you 25% off, which means they're going to charge me 75%. So 100 times 0.75 means right now my discounted price is 75 bucks. But after that, they're going to turn around and add in 6% sales tax. So if I go 75 times 1.06, that gives me that total, plus the $10 shipping and handling, for my total price of $89.50. A composition of function will do this. It'll take you from this number directly to that number. I'm going to combine two functions so that I can do that. So here's what I'd like to do. Remember, composition of functions is written like this. I would like to do the function of f first, and then I would like to follow that with the function of g. So it's going to look like this. You'll see it two different ways. You could be asked to find g following f, so it looks like that. It could also be written as g of f of x. What this means is do the function of f first, and then whatever that answer is, place it into the function of g. When we're working with the composition of functions, it's going to look the same way. I would like to go ahead and find g composition f of x. So here's what I'm going to do. Let me switch ink on you here. I'm going to pick up the function of f, and I'm going to place it into the function of g wherever I see a variable. And then I'm going to simplify it. So it's going to look like this. I'm going to pick up that 0.75x and place it into here. So I'm going to have 1.06 times 0.75x plus 10. And then now I'm going to simplify this. So I get g composition f equal 1.06 times 0.75 would be 0.795 x plus 10. What we just did is we found a formula that whatever your cost is, I can plug that into this formula and it would take me straight to the answer. So if I wanted to plug in 100 real fast, 100 times 0.795 is 79.50 plus 10 puts me at 89.50. So that's the composition of function. I'm going to review one more with you just because we don't do a lot with it today. You'll see a couple of them on the Math Excel assignment, but it's the concept that I need to use when I get to the calculus portion today. So if you will, go to your next little example there. Just some quick review of the composition. Given f of x equal x squared minus 3x plus 6 and g of x equal 2x minus 1, I would like to find f of g of x or f composition g. This little symbol there means following. In layman's terms, it means pick up the function of g, and place it into the function of f wherever you see a variable. So it just looks like this. I'm going to have 2x minus 1 quantity squared minus 3 times 2x minus 1 plus 6. And then I'll just simplify that. That's going to be 4x squared minus 4x plus 1 minus 6x plus 3 plus 6. Combine my like terms, so I got 4x squared minus 10x plus 10. So there is f composition g. I picked up g and placed it into f. Let me go the other way now, so let me erase this mess. I'd like to find g of f of x or g composition f or g following f. What's that basically mean? Pick up your function of f, all of that, and place it into the function of g wherever you see the variable. So it's going to look like this. 2 times the quantity of x squared minus 3x plus 6 minus 1. So I've got 2x squared minus 6x plus 12 minus 1, so plus 11. So there's a real quick review of the composition of functions. You'll see here in a little bit when I show you the chain rule, there's two functions working together at the same time, and sometimes it's kind of hard to see. A couple more things about composition real fast. Not sure why that's there. So here's my next little piece. Write each function as a composition of the other two functions. Basically it's saying make up your own rule, so that once you do f composition g or g composition f, you would get this equation. There's many different answers, so I'll just show you one of them. I'm going to let f of x be x to the 5th. Why did I pick x to the 5th? Some quantity, I don't know what it is, to the 5th power. Well, now I'm going to let g be the part inside the parentheses, 2x squared plus 5. Now I just have to decide if this is a f composition g or g composition f equation. So if you think about it, let's look at f composition g. It says pick up the function of g, which would be that, and place it right there. Well, if I do that, I'm going to have 2x squared plus 5 to the 5th. So there's my answer. So I just made it up. You could have called f of x 2x squared plus 5, the part inside the parentheses. Then you could have called g of x x to the 5th. Your answer would have been f composition g or g composition f. We just got to figure out which one it would be. Well, if I looked at f composition g, that would pick up g and place it into f, and I wouldn't get anything near that. But if I picked up f and plugged it into g, I would be back to where I wanted. So multiple answers on these. Another one real quick. I'm going to let f of x be, I'll go the other way this time. I'm going to let f of x be 5 plus 7x. I'm going to let g of x be the cube root of x then. I just have to decide, is this a f composition g or a g composition f? So I'm going to look at it. If I picked up g and plugged it into f, so if I picked up that cube root of x and plugged it there, I wouldn't get anything near that. So I know it's not that. So here's my answer. Boom. Okay. Hey, and that's about all I'm going to talk about functions for a little bit, composition of functions. I'm going to get into the calculus portion of it, because there's a little shortcut that I need you to try to see. So here goes. Look at your first example there. Here's what I'd like to do. I would like to find this derivative by any means that we know. And then I'm going to do some fancy factoring a little bit as we go. Don't get all worried if you didn't understand factoring, because all the middle pieces here in a second, I don't care if you know them or not. It's just seeing where I'm going. So hang with me for a little bit. I'm going to take this 5x plus 2 quantity squared. I'm going to FOIL it out real fast. So I've got 25x squared plus 20x plus 4. Notice my notation, f of x. Now I'm going to do the derivative. Well, the derivative of that's going to be 50x plus 20. That's my answer, but I'm going to do this to you. I'm going to factor out anything that they have in common. And I spy that they have a 10 in common, which leaves me a 5x plus 2 to the first power. Why did I do that to you? There's a way to go from here to here. So kind of start looking for that. Here's my next one. I got 2x squared plus 3, quantity squared. I'm going to do the same thing. I'm going to FOIL this thing out first. So 2x squared times 2x squared, 4x to the fourth. My middle term is going to be the 2x squared times the 3 doubled. So I'm going to get 12x squared plus 9. Notice my notation, f of x. Now let me go get the derivative, which is going to be 16x cubed plus 24x. So I'm done there. I've now found the derivative, but let me factor this for you. I'm going to take out a 8x, which leaves me a 2x squared plus 3 to the first. Why did I do that again? There's a way to go from here to there, thus bypassing those middle two steps. That's why I'm not real worried if you keep up with me on the factoring right now. I got a fun one for you. I went ahead and wrote this out because it does take a little bit of time. So if you look at 2x plus 3 quantity squared, let me explain what I did here for you, just to save a little bit of time on the video. I applied Pascal's triangle to this. The 2x is my first term, and the 3 is my second term. So I knew when I expanded this out, I was going to have a 2x 3 times and no 3's. And then there's my 3 from my 1, 3, 3, 1. I knew I was going to have a 2x 2 times and a 3 1 time. And then I knew my 2x was going to go down a power. I knew my 3 was going to go up a power. And the last term is cubed. Here's what I got when I simplified it. 8x cubed plus 36x squared plus 54x plus 27. Don't worry about writing it down. Don't panic. I found the derivative, which was 24x squared plus 72x plus 54. I factored out a 6, which left me 4x squared plus 12x plus 9. And then I recognize this as a perfect trinomial, meaning the square root of that term times the square root of that term doubled was the middle term. So long story short, there's the final answer factored. Why do I show you that? There's a way to go from there to there. Look at all those steps that I've skipped out on. So I'm hoping that you kind of starting to think of a pattern or a way to cheat on it a little bit. My next slide, I'm going to do this to you. Here's the ones that we just did. Notice that I had the quantity 5x plus 2 squared. Notice that there's a 10 out front. And notice that the 5x plus 2 was to the first. It started as a squared, but it went down to a first. Check out my next one, the 2x squared plus 3. This quantity started as a squared. It ended up as a first. So that part should sound like the power rule, right? The exponent goes down by 1. What we got to do is figure out where this number out here comes from. Here's that last one that we did. Notice that the 2x plus 3 to the third became 2x plus 3 squared. But see if you can start thinking in a way that that number out front shows up. And then I went ahead and just made up a couple more because I didn't want to take the class time to do it. 6x squared plus 3 quantity cubed. Something that I hope you know for sure. I'm going to see a 6x squared plus 3 squared. So there's that part. We got to figure out where this part comes from. And then let me just talk you through a few more. 5x cubed plus 3 to the 7th. Oh, yuck. Look what my derivative is. 105x squared times 5x cubed plus 3 to the 6th. So this part is the easy part, right? We just got to figure out this part. And it's nicer when you're in class, and then we can kind of talk through it. And a lot of times what happens, somebody sees the answer, or they start almost getting it, and then we can kind of derive it as a class. You're kind of stuck on a video for me to just kind of spoon feed you a little bit. Look at this last one. I had this 9x squared plus 5x to the 8th, so I also have a 9x squared plus 5x to the 7th. Hey, notice I got an 8 out front. And then look at that 18x plus 5. Let me throw this bone to you here. What's the derivative of the parentheses? The derivative of 9x squared plus 5x is 18x plus 5. So notice how that showed up. Okay, hang with me a second now. Let's go back up to the top. What would happen if I applied the power rule to this? That 2 would come down front, so I'd have a 2. I'd have a 5x plus 2 to the first. What would I have to do to get 10? Multiply this thing by 5. Notice this. What's the derivative of 5x plus 2? It's a 5. Check out this 2x squared plus 3 quantity squared. There's a 2 in front. I'm going to bring this 2 down, just like we would the power rule. 2x squared plus 3 to the first. Hey, see this 8x though? The derivative of 2x squared is 4x. 2 times 4x is 8x. Let me jump down to this one. We didn't do this one in class. There's going to be a 3 in the front. So I'm going to have a 3 in the front. A 6x squared plus 3 to the squared. The derivative of 6x squared is 12x. 3 times 12x is 36x. So there's what we got going on so far. Here comes the chain rule definition. Feel free to put this formula on your note card. Let me talk you through it just a little bit before you do that. There's kind of two pieces of the chain rule. It says if I have something that we can find the derivative of, and it's working with two different quantities, meaning a quantity within a quantity. A quantity within a quantity. The derivative of this is, and I've got a better rule here in just a second, the derivative of this is the derivative of the quantity times the quantity. Let me put this in layman's term. If I would like to find the derivative of some quantity to a power, some quantity to the power, it says this: apply the power rule to your quantity. Bring down the n, take away 1, and leave your function alone, and then multiply it by the derivative of whatever's inside your parentheses. So you might at some point pause the video and write down that. You might pause the video and write down that, and then once you see it in action, it really becomes pretty simple. So here goes. I'm going to give you y equal x squared plus 1 quantity cubed, and instead of y prime, we're going to find dy dx. That should be what I have on your notes. So here goes. Dy dx, that's that fancy notation, is this. Apply the power rule to x squared plus 1 to the third. So the 3 comes down. Leave your parentheses alone. Take 1 away from your power. So there I am so far. Here's why it's called the chain rule. There's a chain of events happening. Since I'm working with the quantity, I applied the power rule to this, but I need to multiply by the derivative of whatever's inside your parentheses. So I'm going to multiply by 2x. So my ending answer for this derivative, dy dx, is going to be 3 times 2x is going to be 6x times x squared plus 1 squared. And then we got it. Here comes another one. The derivative of this thing is going to be, bring down this exponent, leave your parentheses alone. So I got 2x cubed plus 6x minus 5 to the 4th. There's the power rule. Here comes the chain rule part of it. The chain rule says times the derivative of whatever's inside your parentheses. So it's definitely going to be a quantity. So times 6x squared plus 6. So there's one form of the answer. Every now and then, Math Excel or the book will say factor it completely. So here's what that means. Check out this 6x squared plus 6. There's a 6 that can be factored out. So if I factored out a 6, I'm left with an x squared plus 1. My ending other answer could be 5 times 6, 30, times 2x cubed plus 6x minus 5 to the 4th, times x squared plus 1. There's my derivative of it using the chain rule. So the power comes down, decrease it, leave your parentheses alone, times the derivative of whatever's inside your parentheses. Here comes my next one, an easy one for you. F of x equal 3x minus 4x squared to the 4th. Well, my derivative, f prime of x, is going to be simply bring down the 4, leave your parentheses alone, take away 1 from the power. Now here comes the chain rule, times the derivative of whatever's inside your parentheses. Since that's definitely going to be a quantity, I need parentheses. 3 minus 8x. There's your answer. Leave it alone. You could take this 4 times that, but it's just more work. So you're done with that answer. Look at your next one if you would. F of x equal 5 over the quantity 2x minus 5 to the 3rd. There's two ways to do this. You could use the quotient rule and get the correct answer. And that's not a bad way. But if you recognize it, the chain rule is nicer. So here's how I'm going to rewrite this. Notice f of x means I'm not doing any calculus yet. I'm going to have 5 times 2x minus 5, since I brought it up out of the denominator, to the negative 3rd. Now I'm ready to go get the derivative. Negative 3 times 5, negative 15, times 2x minus 5. Negative 3 minus 1 is negative 4, times 2, the derivative of the parentheses. Ending answer, negative 15 times 2 is negative 30, over, since that's a negative exponent, 2x minus 5 to the 4th. Got it. But that's the chain rule. It looks like I got 3 or 4 more examples to fly over with you. If you feel you understand it, you can pause the video or fast forward it whenever you want. Otherwise, I'm going to just click through the other ones real fast. It'll take me about another 3 minutes. And here goes your next one. The key thing is just knowing how to write it. So let me get some ink here. I'm going to think of the square root of 3x minus 10 as quantity 3x minus 10 to the 1/2. Now I'm ready to apply the chain rule. So f of x is going to be f prime of x. Bring down your 1/2. Leave your parentheses alone. To the negative 1/2, that's what you get when you subtract 1, times 3. And then how do we write this? It's going to look like this. In the numerator is this 3. In the denominator is a 2. And also in the denominator is a 3x minus 10 to the 1/2, or a square root of 3x minus 10. However you want to write it. It doesn't matter to me. And remember, now that you're in calculus, you're a lot cooler than you were when you're in FST. We get to leave those square roots in the denominator. Here goes my next one. Y equal 5 minus x cubed to the negative 4/3. So I'm going to say dy dx, the derivative of y with respect to x is negative 4/3. 5 minus x cubed, subtract 1, so negative 7/3, times the derivative of whatever's inside the parentheses, which would be negative 3x squared. So the calculus part's all done. dy dx is going to be then, if I take negative 4/3 times negative 3, I'm going to get 4. Positive 4. I'm also going to have an x squared in the numerator. And in the denominator, I'm going to have 5 minus x cubed to the 7/3. And then we're done. Looks like I've just got a couple more, and then I've got this video whipped for you. Here's my next one. I got f of x is 3 over x squared minus 7. You could use the quotient rule, and that would be a-okay. Otherwise, I'm going to write it like this: 3 times x squared minus 7 to the negative 1st. I just brought up the whole quantity. So my derivative is going to be negative 3 x squared minus 7 to the negative 2nd, subtracted 1, times 2x. My simplified final answer, negative 6x in the numerator over x squared minus 7 squared. That's all there is to it. Here's my next to the last one, it looks like. I'm going to rewrite this thing as y equal t squared plus 3t minus 1, since I'm bringing it up out of the denominator, to the negative 2nd. Now I'm ready to go get the derivative. Negative 2 t squared plus 3t minus 1 to the negative 3rd times the quantity 2t plus 3. Ending answer. In the numerator is going to be a negative 2. There's also going to be a 2t plus 3. You could call that negative 4t minus 6 if you want, over t squared plus 3t minus 1 to the 3rd. Then we got it. That's the derivative. And my last one's nothing special. It was just one more that I made up. 4 over x squared minus 9x to the 3rd. I will think of that as 4 times x squared minus 9x to the negative 3rd. Here comes the chain rule, so negative 4 times 3, so I got negative 12. X squared minus 9x to the negative 4th times the derivative of that, 2x minus 9. Ending final answer, I've got negative 12, 2x minus 9, all over x squared minus 9x to the 4th. And that's all there is to it. That's the chain rule there, guys. So add that to your note card. And I went with Math Excel. That way you ought to be able to self-check it. Next time lesson is long enough, there's enough factoring, and there's no way you'd want to type those things into Math Excel. So next time will be a worksheet. So remember, guys, next time we will quiz over the product rule, the quotient rule, the power rule, and any applications that I had. We won't put on the chain rule yet. We're not ready for that. and then we'll go from there. So good luck.